Okay. So what we're going to talk about today are inverse trig functions. So to find inverses of functions, functions have to be 1 to 1, right? Which means they've got to pass the horizontal line test. Is a sine or cosine function 1 to 1? No. Oh, heck no, right? I mean, like, they're so not 1 to 1 because they have this repeating oscillating pattern and a horizontal line intersects them an infinite number of times, right? So remember how when we found inverses of parabolas, we had to just take half of the parabola? We're going to do something similar with the sine function, and we're going to look at just part of it, and we're just going to inverse part of it. So first, graph the sine function between negative 2 pi and positive 2 pi. If I do this enough, hopefully you won't fail me in calculus and not be able to graph this function. Where does sine start? 0. When does it go up to 1? At half pi, great. Back down to 0 at pi, down to negative 1, back up to 2 pi. On your quiz tomorrow, when you have to graph these functions, you do need to label your axes at least a little bit. And there's no reason that those tick marks have to be 1. Like if you need them to be some other number, you can make them some other number. Okay, so how could you take this function and get all of the possible y values but absolutely 0 overlap? Which chunk do you want to look at?
You could have the 0 amplitude.
Okay, so
Let's go from negative half pi to half pi.
yeah, you've already had this class, so you know that. So the point is, like, if you start here, you can't continue that way because you're still not going to be 1 to 1. Does that make sense? That was why that's bad. And so you could go from here to here, right? But that's a little bit weird, isn't it? So the conventional way is to start at this point, which is negative half pi, and go up to half pi. That gets all of the y values, but there's absolutely no doubling up. Does that make sense? So the part you look at is from negative half pi to positive half pi. So the domain of sine, once it's been restricted, will include negative pi halves to pi halves. What's its range going to be?
Negative 1 to 1.
Negative 1 to 1. So that's how you restrict it so that you can find its inverse. So one continuous chunk. Here would be what the unit circle would look like. You're looking at just this part of the unit circle. The top half in that direction, the bottom half in that direction. Does that make sense? So positive pi halves up, negative pi halves down. Okay. Let's go back to a normal size marker. So the inverse sine function, denoted by sine with a negative 1 exponent or arcsine, is defined as the inverse function of sine on the interval from negative pi halves to pi halves, inclusive of those endpoints, so square brackets. So if that's the case, what's the domain of sine going to be once restricted? This thing. So negative pi halves to pi halves. And what's its range going to be?
1 to 1.
Does it actually hit those negative ones and positive 1?
Yes.
Yes, so square brackets there. What happens to domains and ranges in inverses? They switch places. So what is the domain of inverse sine going to be? Negative 1 to 1, exactly. And how about its range? Negative pi over 2 to positive pi over 2. Okay, and so here's how you find values of inverse sine. So when you're asked to find, okay, let me backtrack for a second. So with sine, you input angle, and your output is the sine value of that angle, right? Does that make sense? When you do the inverse, those roles switch. So for the inverse, you input the sine value, and what's your output going to be? Your output is the angle. Output, gosh, can't spell, is the angle. That relationship reverses, right? That's what inverses do. It's their job in life. So if you're asked to find sine inverse of root 2 over 2, you're asking yourself what angle, when plugged into sine, gives you root 2 over 2 on the interval negative pi halves to pi halves. That's the question you have to ask yourself in your head. Sine of what angle gives you root 2 over 2? And the tricky thing is you've got to be in that restricted interval. It's the part that students always forget, is that they've got to be careful what interval they're looking at, because there's a lot to remember.
135.
Well, 135 is not within that interval. So this interval technically is negative 90 to 90. Does that make sense? So it would be 45 degrees, which is an angle of what in radians? Pi over 4. Does that make sense? So the answer to this question is pi over 4. And that will be a substantial portion of your quiz tomorrow, is like just figuring out inverse sine for various values. If you know your unit circle, it's just we kind of already did these, didn't we? Because didn't I already say, I said, okay, find the values of x for which sine of x equals root 2 over 2. And I said, oh, find those values. We did, I was trying to sort of hint at what was going to come. It wasn't just madness, contrary to popular belief. I mean, I'm crazy, but it wasn't only that. Okay, let's try a few. Arc sine of 1/2. So the question you ask yourself is sine of what number gives you a half? And for me, it helps to just look at the half of the unit circle. This is that half of the unit circle. And it's either pi 6 or it's pi thirds, right? It's one of those two. Does that make sense? It's not pi quarters, because at pi quarters, both sine and cosine are root 2 over 2, right? So what were the coordinates at that first point? You go over, and you go up 1/2. And this other one is the opposite, right? 1/2 radical 3 over 2. So which angle of those two, pi 6 or pi thirds, gives the sine to be 1/2? Pi 6. So this is equal to pi 6. Okay, sine of what angle gives me 0? So sine's the y's, right? So it's one of the axes points. Does that make sense? So is it that point, or that point? The first one. Does that make sense? This is the one where the y is 0. Your angle has to be in the interval from negative pi halves to pi halves. So do you say 2 pi? No. No, what do you say?
0.
You say 0. You could also think that the sine graph goes through the origin, so if you flip-flop that x and y point, it still stays 0, 0. Okay, sine of what angle gives you negative root 2 over 2? So this one's a bit different from the previous ones because we're no longer in quadrant 1, we're in quadrant 4, right? Okay, the radical 2 over 2 are the next easiest ones after the axes. Does that make sense? So it's this angle, which is negative pi over 4, exactly. Negative 45 degrees or negative pi over 4. Unless I specify otherwise, I do want your answers in radians, because you guys can all do degrees. Radians are the things that are more tricky for you, and it's going to come up more often in calculus as well. I forgot to put it in my directions, and I should have, so I said it now. Okay, does that make sense? Okay. Arc sine, so arc sine is another way of just saying sine inverse, that's all. So the question you ask yourself is the same. You say sine of what angle gives me 1 in that restricted interval. So what angle in that interval is the y value equal to 1? Pi over 2, awesome. At pi over 2, the coordinate on the unit circle is 0, 1, the y is 1. That's where the sine is 1. Okay, when is the sine equal to root 3 over 2? Pi over 3, awesome. Yeah, because at pi 6, the coordinates were root 3 over 2, 1/2. And at pi thirds, they were 1/2 root 3 over 2. For sine, you're looking at the y, so it's pi over 3. Awesome. Okay. Sine of what number gives you 2? What is the range of sine?
-1 to 1.
Can you ever get a 2 out of sine?
No.
That was kind of a trick question because I didn't put if possible. This is not possible. If you put it in your calculator and your calculator gives you an answer, it's probably because you're in the wrong mode. Although, would that matter? I'm not sure it would. I think your calculator would say domain error. Okay. Now, usually inverses cancel all nice and pretty, right? Now, except for sine and sine inverse, they only cancel if you're within the right domain of this inner function. Okay, so the cancellation will only happen sometimes. So if you have sine of sine inverse, this will be true if the x is in -1 to 1. So that's that inside function having x within the right set of values. Otherwise, you can't say that these things cancel. And this will cancel if that sine of x has stuff within the right values. So what did sine of x have to be restricted to? If x is in negative pi over 2 to pi over 2. And you can still figure out some values of sine inverse of sine if you're not within that range, but the stuff will not cancel. Here is an example where stuff's not going to cancel, and a pretty easy one. Let's do sine inverse. Just add this in like on the right side. We've got a little bit of blank space. Sine inverse of sine of 3 pi over 2. So 3 pi over 2 is not in negative pi halves to pi halves. Does that make sense? Okay. So in that case, what you have to do is just work out what sine of 3 pi halves is. So what is sine of 3 pi halves?
-1.
-1. And then sine inverse of -1, what's it going to be? So when does sine equal -1 in the interval we want?
-pi over 2.
-pi over 2. Notice how it did not give you 3 pi halves. Does that make sense? So just watch out for that, okay? And I think actually as a good rule of thumb, until you get super comfortable with these domains, you're never going to be wrong if you do it this way. Do you see what I'm saying? Like if you just work out what the inside thing is and then apply the inverse function to whatever you get, you're always going to get the right answer, even if it does work out that they cancel. So that would be my suggestion, is try the method that always works as opposed to the one that sometimes works. Does that make sense? Okay. Well, unfortunately, Alex will do some stuff like this and make you just kind of know the pattern, because these are nice ones that can work out. So is 1.2 within the appropriate range?
No.
It's not, I think it actually is, but it's not super obvious. So for this one, we would have needed the x to be in negative pi over 2 to positive pi over 2, right? That's what I wrote above. Give me a super easy estimate of what pi over 2 approximately is. It's about 1.5, because pi is about 3, right? Does that make sense? This is a ish, negative 1.5-ish to 1.5-ish. I mean, it's actually, different than that, but that's an approximation, right? So is 1.2 within that interval?
Yes.
It actually is. So in that case, you can say that these cancel, and you can say that this is 1.2. That's all right. Okay, sine of sine inverse of 0.7. Okay, so for that one, you needed your x to be in, I think it was negative 1 to 1, right? So in that case, is 0.7 within that set of values? Yeah, so they can cancel. Okay, is this one within the range of values we need?
No.
No. And it actually turns out, like I had to do this with the calculator because there's kind of no other great way, that this is actually negative 1.14 approximately when you say, use a calculator to evaluate that. So it does say to use them if possible. And this one you could also maybe have said the cancellation is not possible. If I give you one where cancellation is not possible, it's going to be one where you can actually work out the sine and the cosine, like on that one that I made up just above. Does that make sense? Okay. Now here's something else that kind of comes up in calc a fair amount. Find these, and it's a little bit tricky, but I think you can get it. Find the exact values without using a calculator. So cosine and sine inverse are not going to cancel, right? So because they're not, even if they were inverses, great, but it's cosine, not sine, right? So here is how you figure stuff like this out. This sine inverse of 2/3, that's an angle, right? Does that make sense? As in when you input a number into a sine inverse, the output is an angle, right? So let's give it an angle letter. Sine inverse of 2/3 is equal to some angle theta. Theta is the letter that angles get, because we like Greek. That's the same as saying sine of theta equals 2/3. Does that make sense? Okay. Now you can go back to your SOHCAHTOA happy place and you can use it. So remember, if you have a triangle and this is your angle, and actually because we're working in that first quadrant, we do have right triangle trigonometry. Does that make sense? Okay. So sine, I can't do it in either way. So sine is the opposite over hypotenuse. So in that little triangle that I drew, what is the opposite side?
The right one on the 2.
It'd be 2, and it's 2, yep. What other side do we know the length of? The hypotenuse is 3. And how could you figure out the length of that side? Your favorite theorem, yep, you'd have, well, call that A. A squared plus 2 squared equals 3 squared. So A squared is going to equal 5. Do you guys buy that? Because I sometimes subtract wrong, although I'm less brain dead today. So A equals root 5, right? Okay. Now here is the craziness. You've got cosine of sine inverse of 2/3. Sine inverse of 2/3 is equal to theta. So this becomes cosine of theta. Does that make sense? Okay, and then you find cosine of theta using that triangle. It's pretty clever. So cosine is the adjacent over the hypotenuse, right? So this will be root 5 over 3. And so this part, the sine inverse of 2/3 part, that's used in the construction of the triangle. And then you use the triangle to find cosine of your angle. Does that make sense? Okay, it's a bit strange. I do buy that, but Okay. Awesome. Okay. So this next one's a bit different because of the negative on the sine inverse. So what quadrant does that mean that we're in? This triangle is technically kind of in quadrant 1. Does that make sense? This one's going to be in the bottom one, which is actually quadrant 4, right? Okay, so sine inverse, but you proceed the same way. Sine inverse of 1 over root 5, you say, okay, that's equal to some angle theta. So sine of theta is negative 1 over root 5. And how you can deal with that negative is you can draw your triangle just down in this quadrant. Oh, is that... I did use some different stuff on my notes, and I'm actually hoping this will work. Well, we'll give it a try. So there's theta. I think in this case, you have to use that definition that when you find the sine, that numerator is your y value, and the denominator is the hypotenuse. And I guess that for now still is opposite and hypotenuse, right? Okay. I'm just a little bit afraid that that definition is going to break, that's all. So how would you figure out that other side?
Pythagoras.
Pythagoras again, yep. So a squared plus 1 would equal 5, right? So a squared equals 4. So what is the other side? A equals 2. Okay, I remain confident that my method will work. So this original problem we had is equal to tangent of that angle theta, because that angle we set it equal to theta. And using that triangle that we drew, one definition of tangent was that it was the y value over the x value, right? So what is the y value for that triangle? Yep, negative 1/2. Personally, me care more about positive things, okay? That's my personal preference, but negative things might also come up, and Alex and other professors might care more about those. So just, it's good to be aware that they exist.
So you kind of ignore the negative sign?
Well, the negative sign meant the triangle got drawn in that quadrant.
Oh, okay.
Does that make sense? And in which you see how I did actually make one of the sides negative? Like I did actually call that side negative 1.
I meant the inverse.
Oh, yeah, the inverse sign just means inverse, and you actually make a good point that I probably should point out, is that this is something that's tricky about math, and it's just notation is like, has been used, and you have to remember this is true. Things like x to the negative 1, that means 1 over x, right? Unfortunately, sine to the negative 1x does not mean 1 over sine x. Okay, that is a thing that is not true. That little negative 1 just means inverse function. So, yeah, and this name with the inverse is equal to arcsine. There are two names, and I think that the reason that the second name has gained popularity is nobody makes this mistake with it. Does that make sense? Because there's no little negative 1 exponent there that makes you think that it must be 1 over something. And that's tricky because I don't think we've done this yet, but stuff like sine squared x, that does mean sine of x, the quantity squared. So if you want to write sine of x to the negative 1 power, you've got to do parentheses sine of x, negative 1 power, like that. But we'll discuss stuff like this more later on. We talk about some identities and things with trig. Yeah, but the negative 1 just means inverse. It's a way of saying how the sine function, how it relates to, how sine inverse relates to sine. It states that their relationship is that they're inverses of each other. Okay. All right, so now we're going to do inverse cosine. So first, graph the cosine function. So if this is 2 pi and this is negative 2 pi, and you guys are getting really awesome at graphing these functions because I keep beating you with them. Metaphorically, not actually beating you. I don't hit kids. Okay, so technically no, you're kids, so I can smack you around all I want, but I'm just kidding. Okay, so where does, actually some of you are kids, so I can't. So where does this function start? 0, 1. By pi halves, you're at 0. By pi, you're at negative 1. I mean, if you fall asleep in class, I might throw an eraser at you, but you know, something soft and squishy. Yeah. I'm not really going to grade your art, but give it the right, get the points right. Does that make sense? And you know, give it the right shape. Try to not draw V's. Does that make sense? Because they're not V shaped. They are actually a little bit curvy. Yeah, I'm not going to really grade your art super harshly.
Like some of them look different sizes, just making sure.
Yeah, it's all good. Okay, so if you want to make this thing 1 to 1, you want to have the part that gets every single y value but does not have any overlap. So what's the easiest thing to do you think? 0 to pi. Look at just that part. So that's how you're going to restrict cosine to make it 1 to 1. You're going to go from 0 to pi. So in the unit circle, that means we're looking at the top half of it, right? Okay. No problem.
Why is it default to start from 0 and then go to pi rather than starting at negative pi and then going to 0?
I think it's just more common to talk about positive angles. I mean, does that make sense? It's the same thing for the, I mean, there's really no reason with the square root function you took that half and not that half, right? But I think that the idea being is just that positives are a bit simpler. That's my suspicion. But there, you could have done negative pi to 0. That would have done the same thing.
I was just gonna ask, how can you pick that side and not another side?
Yeah, I mean, this side could also be picked as an, it's just that it's convention to choose the positive angles instead. That's all. So people just had to agree on which one to choose. And apparently, according to your textbook, when you do inverse functions for secant, cosecant, and cotangent, which we're not going to do because I think they're silly, there isn't even really agreement on what part to pick. So, but for this one and for the others we're going to do today, it pretty much, this is definitely almost always 0 to pi. But negative pi to 0 would work. You could like redo math with all those values. But let's not reinvent the wheel. Let's just accept that we should go 0 to pi. So here we go, inverse cosine function. So inverse cosine function, which is denoted, I bet English, yep. Okay, so this is defined as the inverse function of cosine on the interval from 0 to pi. So the domain is going to be 0 to pi. What's the range going to be? What were all the y values that your cosine function hit? Negative 1 to 1. So what will be the domain of the inverse function? Negative 1 to 1. And the range will be 0 to pi. Okay, and the same kind of thing. If you're asked to find cosine inverse of 1/2, you're asking yourself what angle, when plugged into cosine, gives you 1/2 on the interval from 0 to pi. If I write the wrong thing there, it's just because 0 to pi is such a habit. 0 to pi. So what would that be anyway? When would the cosine be 1/2? Would it be pi thirds or would it be pi over pi sixths or pi thirds? That'd be pi thirds. Okay, so let's find some values of inverse cosine. So arc cosine of root 3 over 2, it's saying, okay, cosine of what gives me root 3 over 2, specifically on the interval from 0 to pi. So look at the top half of your unit circle, that's 0 to pi. Are you in quadrant 1 or are you in quadrant 2? Or let's start with a different question. Are the cosines, in which quadrant are the cosines positive?
One.
Mhm, in which quadrant are the cosines negative? Because cosine is the x part, right? So this first point, the coordinates are root 3 over 2 and 1/2. And the second one is 1/2 and root 3 over 2. Does that make sense? Okay. So if we're looking at the cosine, we're looking at the x values, right? And this is saying which angle gives me the x of root 3 over 2?
Over 6.
Pi over 6. Okay. Cosine of what gives you negative root 2 over 2? So which quadrant are you in for that one? The second one. And the root 2 over 2 is those come from the 45-degree angles, right? But I just note that as in radians.
3 pi 4.
3 pi fourths. Great. Okay. Cosine of what angle gives you 0? So is it 0? No, because that's the point. 1, 0, and the cosine is 1 there. Right? I mean, not tricky, not be tricked. The coordinates at this pi halves point are 0, 1, right? So that is pi halves. Okay. And you have a similar kind of trickiness with the cancellations. So cosine of cosine inverse of x is going to equal x if x is in, so cosine inverse needs to be in the proper place. So what would be the domain of cosine inverse? Negative 1 to 1. And this will cancel if the cosine's in the proper place. So what do we have to restrict cosine to? 0 to pi. And if you're not, and also just for reference, this one is approximately 0 to 3.14. That one's a little bit easier to see what it is, right? Okay, so would this first one be something that could cancel?
Yes.
Yes. And that's because point 2 needed to be between negative 1 and 1, and it is. Great. How about part B? Would that cancel?
No.
I think it would.
Yes.
See how the order's reversed, so that now you have to have the cosine must be between 0 and pi.
Yes.
So that does cancel. I'm going to change part C so that they don't, and we're going to actually just work one out. So let's do 5 pi quarters. Oh shoot, I can't do it that way. Never mind. Actually, I can't think of a way to make that one break. Change it back to what it, scribble it out completely. Sorry. Because I want you to see some in case you see them on Alex or the homework. So if I gave you cosine inverse of cosine of 5 pi quarters, that's what I meant to do, sorry. So in this instance, 5 pi quarters is bigger than pi, so these won't, the inverse and the function won't cancel out immediately. So in that case, work out what cosine of 5 pi quarters is. So 5 pi quarters is in which quadrant?
3.
3. It's this angle, right? What is the cosine at that point? Negative radical 2 over 2. So cosine inverse of negative radical 2 over 2. And didn't we work out what cosine inverse of negative radical 2 over 2 was? Like up above?
Yeah, we did.
We did. So what was that?
3 pi over 4.
3 pi over 4. Okay. So another one of those weird triangle things. So sine of cosine inverse of -1/3. So here you've got cosine inverse of -1/3. So if I say, okay, cosine inverse of -1/3, that gives me some angle. So -1/3 is cosine of that angle. So I'm going to draw my triangle in this quadrant. That's my theta. What is the 1 in the triangle? Which part of it? The side to side, the up and down, or the hypotenuse?
Why?
It's actually the x, because it's cosine this time, not sine. And then what is the 3? The hypotenuse. Yep. Yeah, it's a great word. And then if you use the Pythagorean theorem, that side I'm pretty sure is square root of 8. You guys buy that? Okay. It's going to be useful to do those things kind of quickly in your head. Okay, now using that triangle, find sine of that angle. Using the fact that another definition is that you can take sine as the y over the hypotenuse. So sine will be √8/3, as in not negative, right? Okay, awesome. I must have made a bit of a typo on this part B1, so let's change that cosine to a, I bet I meant cotangent. I do that all the time. As in I put a T, an S instead of a T. Okay, so same idea, right? So cosine inverse of -1/√5 is equal to some angle theta. -1/√5 is cosine of that angle theta. So we're still in quadrant 2. Actually, the base of the triangle is still -1, right? What's the hypotenuse this time? And then what's the other side? 2. And there's your angle theta. Now we're asked to find cotangent of that angle theta. Does it make sense that cotangent is the reciprocal of what other function? Of tangent? So tangent would be sine over cosine, or in other words, it'd be 2/1, 2 over -1, right? And this one is the reciprocal of that, right? So this one will be -1/2. It'd also be okay to do sine over cosine, which because you're going to have two denominators that are both √5, and those will also cancel. Well, I guess cosine over sine for cotangent. Yeah, sorry. Okay. Now last one, we did inverse sine, inverse cosine. What do you think's next? Inverse tangent. Seem excited. Woo! Okay, well, at least pretend. That might make it a little better. Yay! All right, so we're going to graph the tangent function. I'm just going to superimpose and say that this is my negative pi halves, and that one is my positive pi halves, which makes this little angle there pi quarters, and that little angle there negative pi quarters. And I'm going to call this 1 and call this -1. Okay, so tell me one point that tangent goes through. 0, 0. Okay, tell me one other point that tangent goes through.
4, 1.
Awesome. One more point.
-pi/4, or, yeah, -1.
Awesome. And then it has asymptotes at pi halves and negative pi halves, right? And that pattern repeats, right? It again goes. And so is this function 1-to-1?
No.
Heck no. But what do you think the most common chunk to look at is?
Negative pi over 2.
Negative, you look at this part, you look at negative pi over 2 to pi over 2. Oh, it's the same domain restriction as inverse sine, except for the one thing is that you actually can't include the negative pi halves and pi halves because tangent's undefined at those points. This is actually the one time I'm going to graph the inverse. So this is the graph of the function f. What we're going to do is we're going to flip-flop the x's and the y's. So these things that are vertical asymptotes, they're like x equals that number, and it's x equals that number, right? When you flip-flop the x's and the y's, like when we did e to the x and ln of x, e to the x looked something like this, right? And ln x looked something like this, right? The horizontal asymptote became a vertical asymptote, right? So the same thing's going to happen here. These vertical asymptotes, they're going to become horizontal asymptotes. Does that make sense? So somewhere at pi over 2, you're going to have a horizontal asymptote. And at negative pi over 2, you're going to have another one. Those are now y equals those numbers. The point 0, 0 flip-flops and stays 0, 0, right? This point pi quarters 1, it flip-flops, and it's kind of hard because the axes are unequal to graph it, but same thing, right? And the function will look about like this. It's going to now approach that asymptote and approach that asymptote. Remember that what was the relationship between the graphs of the inverses? Reflection over the diagonal, actually.
Yeah.
Which officially is reflection over the y and the x-axis at the same time. But the point is that the vertical asymptotes become horizontal asymptotes. And that's probably the first, so anyhow, that's what the picture of inverse tan looks like. And we'll spend more time on that, on the graph, specifically on Monday. That was my plan.
Are we graphing any of the other ones on Monday?
Yeah, we will, but their pictures are a little bit less interesting because they're basically boring. This is the one that has interesting behavior. You also see this one a lot more. Like I ask my calculus kids about this all the time because they don't remember it and I want to make them remember it. So what happens as x goes to infinity? What happens to inverse tan as x gets large? What does the y get close to when x gets large? Pi over 2. What happens as the y gets infinitely negative? It goes to negative pi halves, right? Okay. Anywho, that's what the picture of inverse tan looks like. So inverse tangent, denoted, copy and paste error, denoted by tan with a -1, or arctan, is the inverse of tangent on the interval from negative pi halves to pi halves. Only difference is you don't include the endpoints. So in this restricted universe, tangent has domain negative pi halves to pi halves. What's the range of tangent? Minus infinity to infinity, or you could use the real number sign. Tan inverse x or arctan x has domain or all real numbers, meaning you can input anything you want. What are the outputs you're going to get? Minus pi over 2 to pi over 2. So, for example, if you're asked to find inverse tangent of 1, you ask yourself what angle, when plugged into tangent, gives me 1 on the interval from negative pi over 2 to pi over 2. And it's slightly more tricky, but if tangent gave you 1, the sine and cosine had to be equal, right?
Yeah.
And what angle are sine and cosine equal? Exactly, 45 degrees or pi over 4. Okay? I think once you get the idea of what an inverse is, and just, if you know your unit circle, these things aren't actually that bad to find. The only tricky thing is that restricted domain. That's the trickiest thing. Okay, so tan inverse of 0. So tangent of what angle gives you 0? So look at your unit circle in this interval. And I'm going to write down these points. This is the point 1, 0. This is the point 0, -1. And this is the point 0, 1. Tangent does the y divided by the x, right? So can you do 1 divided by 0?
No.
No. Can you do negative 1 divided by 0? No. Can you do 0 over 1?
Yes.
That's going to give you 0, right? So inverse tangent of 0 is 0. You could also tell that was true because the inverse tangent function's graph goes through the origin, meaning when you input 0, you get out 0. We already kind of did inverse tangent of 1, right? That's pi quarters. Because you're asking yourself, okay, tangent of what angle gives me pi quarter, crap, not pi quarters, gives me 1, which means the sine and cosine have to be the exact same thing. To make it more interesting, what if I'd asked you for inverse tangent of negative 1? So that's not this angle, right? If you're looking for when does tangent equal negative 1, sine and cosine must be equal except for they're the opposite sign. Does that make sense? So that's
Quadrant 4.
quadrant 4, and what is that angle? Negative pi over 4. Oh man, arctan root 3. So tangent of what number gives you root 3? And I see root 3 and I'm thinking it's got to be a pi over 6 or a pi over 3, right? And so I'll write down what their coordinates are. At pi 6, we've got root 3 over 2 and a half. And at pi thirds, we've got 1/2 root 3 over 2. And we do the sine, which is the y, divided by the x. So if we do 1/2 over root 3 over 2, 1/2 over root 3 over 2, we get 1 over root 3, right? And if we do this one, if we do root 3 over 2 over 1/2, what do we get? Root 3. So this is pi thirds. Okay. There we go. All right, cancellation things. So this will happen if inverse tangent is in the right place. So what's the domain of inverse tangent? All real numbers, so that's actually not hard. There you go. That one always works. This will be true if tangent's in the right place. So where does tangent have to be? Negative pi over 2 to pi over 2. Exactly. Okay. Looks like I read my mind. So what is arctan of negative 1? Negative pi over 4. So here, the only restriction was this needed to be in negative pi over 2 to pi over 2. So is that true? Yeah, so that can cancel and just give us 0.63. This one, this had to be in all real numbers. So is 43 a real number? I ain't seen no I. That's 43. Okay, so you can expect in your quiz tomorrow to be asked like lots of questions about find inverse tangent of this and find inverse sine of that. There's stuff like that on there, but the graphs are not on there or anything like that. And then also you've got to graph some sine and cosine functions, but honestly nothing quite as tricky as what you did in class. There's some stretching both ways, some finding periods of functions. Does that make sense?
Are we gonna be doing that to like the cosecant stuff?
There